Chlorine is one of the most important chemicals produced in the world today. It was discovered more than 200 years ago, and the word chlorine comes from the Greek word for green. Commercial production of chlorine began at the end of last century and came to Australia at the end of World War I. Orica began working with chlorine in 1936 and at the end of World War II built and commissioned a new plant at Botany in New South Wales. Chlorine has a long and safe history of production and use. Several thousand tonnes are utilised every year throughout Australia, with customers boasting sound safety records. Chlorine is a safe and sure chemical, meeting the needs of today's environmentally conscious society. Despite an excellent safety record, it's essential for all chlorine users to know the chemical they're handling, its properties, health effects, containers and their valves, as well as how to handle emergencies, including first aid and protective equipment. That's what this video is all about. As a gas, chlorine is heavier than air and may accumulate in low places. It will, however, rise quickly with even a slight breeze. In high concentrations, chlorine is a greenish-yellow colour, but this colour only becomes visible at concentrations much greater than danger level. Similar to LP gas, chlorine is supplied as a liquid under pressure. Chlorine is not flammable, but may assist a fire because, as a gas, it can take the place of oxygen and may react violently with some flammable materials. Dry chlorine gas at normal temperatures isn't corrosive to steel or other metals. Moisture, even in traces, will cause chlorine to become highly corrosive. Iron or steel heated to above 250 degrees Celsius will burn in chlorine. At temperatures above 100 degrees Celsius, the corrosion rate of steel dramatically increases. Ammonia fumes create white clouds when in contact with chlorine, and so is the most commonly used chlorine leak detection system. Liquefied chlorine gas expands greatly with increases in temperature. Pipes can burst if the chemical is trapped between two valves, and containers can rupture if overfilled. Chlorine gas, when inhaled, creates an acidic solution in the nose and the throat, which causes severe irritation. Swelling can occur, which constricts the airway. This is evidenced in a victim by coughing and gasping for breath. If exposure is minor, recovery follows after returning to fresh air. If the exposure to chlorine gas was extended, however, medical attention should be sought immediately. Different concentrations of chlorine vary in their physical effects. Let's have a look at some examples of chlorine concentrations in practical terms. In a room of this size, 1 part per million is the equivalent to a mug full of chlorine. If you stood in this room for 8 hours, you'd feel no noticeable effect. 4 parts per million is like 1 drink bottle full of chlorine. You could smell the gas, and several hours of exposure would cause a sore throat and watering eyes. 15 parts per million is like 4 drink bottles full of chlorine. A few minutes exposure would leave you with sore eyes and throat. 30 parts per million, the equivalent of 8 drink bottles full, would make you cough immediately, and you could only stay in the room about 30 minutes before feeling severe effects. 50 parts per million, 1 large plastic container, would cause immediate severe distress. And 1,000 parts per million, 20 times that amount, could prove fatal unless you escaped from the room within a few breaths. Should someone be exposed to chlorine, they will require immediate first aid attention. Firstly, remove the victim to fresh air. The rescuer must wear breathing apparatus. If the victim is conscious, place them in a comfortable position, usually sitting up, leaning forward. Seek medical attention if the exposure has been more than minor. If eyes or skin have been irritated by chlorine, wash thoroughly for 15 minutes with fresh running water. Badly contaminated clothing should be removed from the victim to prevent further skin burns. Don't apply eye drops, skin ointments or creams. If the victim is unconscious and has stopped breathing, follow standard CPR procedures to restore breathing and/or heartbeat. Chlorine is supplied as a liquid under pressure in steel cylinders and drums of various sizes. These include 4.5 and 33 kilogram units, of which there are a few, as well as the more common 70 kilogram tall cylinder. The chemical is also supplied in 920 kilogram drums, of which there are two types: the Columbiana design with forge welded ends and the John Thompson style with fusion welds. These drums have inspection plugs made of solid steel, not fusible plugs as in the United States, and all drums are fitted with cradles for safe transport. The top valve on the drum draws gas. The bottom draws liquid. All chlorine containers are check weighed on return to the factory. If any weight change is detected, they're cleaned out and internally inspected. This is in addition to the normal scheduled inspection and testing procedures. Chlorine cylinder and drum valves are based on a modified Chlorine Institute design, providing reliability and safety if used correctly. The valve has a special Monel spindle and should not be used as a control valve. If it is used in this way, spindle nose erosion could result. Only valve keys of the correct length and hole size should be used to open and close valves. If not, the valve spindles may become damaged. There's a variety of protective equipment which should be serviced and on hand when using chlorine. Canister respirators are to be used for escape purposes only, and should never be used to enter an area where a chlorine leak is occurring. Canisters have a short life and there's no warning when they'll run out. Self-contained breathing apparatus, or BA gear, should be used when entering an area where there is a leak. Modern breathing apparatus has a positive pressure around the face mask to ensure that if the mask leaks, air leaks out, gas doesn't leak in. Full protective clothing, although not required for low concentration gas leaks, must be worn if there is any danger of liquid chlorine contact. Protective equipment of any type should not be kept in the chlorine store, but should be located at least 10 metres away upwind of the prevailing wind direction. Regular training and practice in the use of these types of equipment is vital. If chlorine containers are handled correctly and care is taken when connecting them to or disconnecting them from the chlorinator, leaks shouldn't occur. But if a leak does occur, you should know how to handle it safely. All chlorine users should have an emergency plan. Then, if the alarm is raised, all personnel will know what to do and will be able to act quickly and calmly. Orica is happy to assist with the preparation and assessment of emergency plans. Once a plan is in place, it's essential to maintain regular drills so that personnel are always familiar with equipment and procedures. Should a leak occur on site, there are a series of steps which must be followed. Firstly, raise the alarm. Alert anyone who may be downwind of the leak and evacuate the area if needed. If the leak is major and is likely to affect people outside of your site, police and fire brigade should be notified. Next, with full BA gear, assess the leak's size and probable cause. It is essential that anyone moving into a leak area wear the appropriate protective gear. The person who rushes in without protection or uses only a canister may become an extra casualty. Shut the valves on the chlorine containers and on the chlorine pipework. This simple procedure will stop almost all chlorine leaks. Only the extremely rare leaks from the body of the container are not stopped by this method. Once the situation is under control, rectify the cause of the leak as soon as possible. If you cannot stop the leak by these means, contact Orica via the emergency response number 1-800-033-111. Orica provides this toll-free number at any time of the day or night. The emergency coordinator has the full list of current expert personnel in all states and can enlist help from our factories, which operate 24 hours a day. Orica personnel have access to specialised equipment for leak control, including a number of types of capping apparatus used for the extremely rare leaks that can't be stopped by shutting the cylinder or drum valve. In a fire situation, the main danger is that chlorine containers may rupture violently due to an extreme build-up of pressure. In practice, this violent rupture very seldom occurs. Any flame impingement or contact with burning debris leads to rapid thinning of metal at the hotspot. The effect being like a bursting disc allowing the gas to escape, frequently going unnoticed because the thermal updraft from the fire causes rapid dilution. Firefighters should attempt to keep drums and cylinders cool. Firstly, if safe to do so, move containers to safety. And where possible, spray water on the upper surfaces of any other containers to keep them cool. If the containers cannot be kept cool, then everyone, including all firefighters, must remain at a safe distance. Firefighters wearing breathing apparatus also have a role to play in reducing the danger from a chlorine leak where no fire is involved. The gas cloud downwind of a leak may be partially diluted by using fog nozzles directed up and across the gas path, being careful not to spray directly onto a leaking container, as it will only make the leak worse by warming the container and corroding the hull. In the event of a major liquid leak, water should not be sprayed on any liquid pool that forms. It is now no longer recommended that foam be applied except after assessment by experts. In almost all cases, it's better to cover the surface with a sheet of plastic, if possible and safe to do so. Let's now briefly review what we've covered so far. Chlorine, when used with care, provides no hazard. But we should all know what to do in case a leak occurs. We've looked at some of the properties of chlorine, and we've seen how it affects us physically. First aid procedures for treating the victim of a chlorine exposure have been explained. We looked at the types of cylinders and drums in which the chemical is supplied, and examined the valves on these containers. In reviewing the various alternatives in protective equipment, you've seen in what situations they're appropriate. We've looked at the emergency plan and its importance, as well as the emergency procedures for responding to a chlorine leak. Finally, we've looked at the handling of a fire in an area where chlorine is stored, and the use of fog nozzles to disperse a chlorine leak. In part 2, we're going to look at helpful hints on preventing chlorine leaks, transportation, storage and connecting chlorine containers to your system.
Orica is here to help you with any of your chemical needs. An Orica technical expert is only a phone call away and can assist you to keep chlorine safe and sure. These men know how to handle chlorine. They follow a careful and methodical work procedure. It's only when people cut corners and make simple mistakes that leaks occur. In this video, we aim to help you avoid those mistakes.
In this video on preventing chlorine leaks, we're going to look at 5 possible problem areas. Firstly, transportation, storage, connections, maintenance and good plant design. Bill here and other carriers like him carry thousands of tons of chlorine millions of kilometres without incident. However, Bill takes precautions every time he takes a load, even if it's only a few hundred metres down the road.
The guide to transporting chlorine safely is the Australian Dangerous Goods Code. Let's have a close look at the main regulations and recommendations.
Cylinders may be carried upright in special cages. If such cages are not available, cylinders must be loaded horizontally. For horizontal loading, the truck tray must have a coaming 25 millimetres high to prevent movement. For stability, cylinders should not be stacked more than 3 high. The cylinders must be secured by chains or 2 webbing belts. In each case, correct tensioning is required. Lastly, the cylinders must be wholly within the perimeter of the truck tray. Securing drums of chlorine is a little different. Webbing belts are not allowed. 2 chains must be used, each capable of taking a 5-ton load. No more than 3 drums are to be secured by each pair of chains. 3 methods of loading drums onto trucks may be used. With this method, you're required to display an emergency information panel on the rear of the truck, and you should leave enough space between the rows to be able to gain access to drum valves. In this method, the emergency information panels are required on each side of the truck. As you can see, a combination of the 2 previous methods can be used, and no emergency information panels are required as long as the ones on the drums are visible to both the sides and the rear. Every driver transporting chlorine must have a dangerous goods licence covering Class 2.3 toxic gas.
Every truck carting chlorine drums or cylinders must carry a range of safety equipment.
Firstly, short-term breathing apparatus for escape purposes. Thermally insulated gloves or gauntlets. Gas-tight goggles. An eye wash kit. Electric torch in working condition. 1 60B or 2 30B rating dry powder fire extinguishers. 3 properly affixed signs.
and 2 emergency procedure guides, carried in this holder.
Leaks rarely occur in storage areas that conform to Australian standard AS 2927, which basically suggests that storage areas be separate from work areas and public places. Provide easy access to containers. Have good ventilation, preferably with a cross draft at the valve end of containers and chlorinator unit. Doors that open outwards. Signs in the relevant places. And have provision for self-contained breathing sets and/or canister escape respirators. Never store flammable materials in chlorine areas, which should also be kept tidy and free of rubbish.
Leaks rarely occur as the result of damage from falls or collisions. Common sense and careful handling will ensure that this good record continues.
An Orica-designed lifting beam can assist greatly in the handling of drums, either with a hoist such as this, or with a forklift truck. In either case, at least a 2-ton lift capacity is required.
For safety's sake, drums must never be stacked more than 2 high in storage.
Cylinders must be treated with care, as they can easily roll. When moving with forklift and pallet, the cylinders must be secured before moving off. Always use chains or clamps when storing cylinders upright. When not in use, containers should have their protective covers in place.
The majority of leaks occur when containers are being connected to or disconnected from the system. There are 5 main causes.
Washers being left out, or old washers being reused. Valves not being shut properly. Breakage of flexible connectors. Piping joints not fully tightened. And gland leaks.
You will have noticed in those last scenes someone using this handy device to test for chlorine leaks. It's a simple squeeze bottle with a 5% solution of ammonia and water in the bottom.
By blowing ammonia-laden air near a suspected leak, white clouds are formed when contact is made with chlorine.
And one other common sense thing, whenever you work on chlorine equipment, you should always try to work upwind so that any chlorine gas will travel away from you.
To prevent valve spindles of both drums and cylinders from vibrating open during transportation, the gland nuts may be tightened more than is necessary for normal operation.
Because the glands can be very tight, the valve may prove difficult to open.
And the valve spindle could be damaged by the force required.
And here's how to adjust the gland.
First, check that the valve is still closed using the special valve key available from Orica. Next, make sure the outlet cap is firmly in position before adjusting the gland. Now, carefully loosen the gland nut, making sure you don't completely undo it. Finally, retighten the gland nut to just slightly more than finger tight.
If the valve gland leaks in service, tighten the nut a little more. Should this still not stop the leak, or if in the first instance you can't open the valve, set the container aside and obtain another.
Tag the faulty container, giving details on the tag, and arrange for it to be returned to Orica. Carefully slacken the valve outlet cap nut, and using the ammonia bottle, check for any leakage of chlorine before removing the cap nut. Check both coupling faces are clean, while making sure that the fibre wad has been removed. Fit a new washer to the coupling, and do up the connection by hand to avoid cross-threading. Tighten the coupling using a second spanner to prevent twisting of the flexible piping. While leaving all other valves closed, crack open the container valve, then shut it again. This will allow a small amount of chlorine into the coupling. Check for leaks with the ammonia test bottle. If no leaks are detected, open the container valve 1 1/4 turns and again check for leaks. Now, crack open the auxiliary valve on the flexible connection and shut it. Again, check for leaks. Continue working down the line, one valve at a time, until the system is fully commissioned.
By being methodical, you can avoid any major leaks, as you'll find the leak while only a small amount of chlorine is present.
To disconnect a chlorine container, first shut the container valve. Next, shut the valve on the flexible connection. Also shut the valve on the fixed pipework. Using 2 spanners, carefully crack open the coupling and allow a short time for the small amount of chlorine in the coupling to disperse. Then check for leaks using the ammonia bottle. If no leak is detected, disconnect the coupling and replace the cap nut, making sure the fibre wad is in place.
As these empty containers frequently contain enough gas to cause serious problems, you must treat them exactly as if they were full, and that is with a lot of respect.
Replace the protection cap ready for return to Orica. In both connecting or disconnecting containers, the use of breathing apparatus is an optional additional safeguard in most cases, but should be regarded as essential if working alone in a remote location or if you're working with a road tanker.
When maintaining chlorine equipment, it's necessary to allow for the special properties of the gas.
Chlorine isn't flammable by itself, but it will assist a fire by taking the place of oxygen and can react violently with some flammable materials, such as oils and greases, so they should not be used on chlorine equipment. Iron or steel heated to above 250 degrees Celsius will burn in chlorine. At temperatures above 100 degrees Celsius, the corrosion rate of steel dramatically increases. Because of this, you must never weld or use heat on chlorine pipes or equipment that may contain chlorine. Where copper tubing is used for flexible pressure connections between the chlorine container and fixed pipework, it will work harden in use and should be replaced periodically. Replace immediately if the tubing is kinked or twisted. If any doubt exists that a line may still contain chlorine, breathing apparatus should be worn as a precaution when breaking the line for maintenance. Dry chlorine gas at normal temperatures is not corrosive to steel or other metals, but the addition of moisture, even in traces, will cause chlorine to become highly corrosive. Because of this, pipework in all chlorine installations should be sealed off during any maintenance, as even small amounts of moisture can cause massive corrosion. If air has been allowed into pipework, it must be dried out, preferably with a small flow of dry nitrogen gas for 1 or 2 days. When recommissioning after maintenance, it's vital that the check and test procedure shown earlier be followed right through the system.
An accident may never happen, but if it does, your regular inspections and maintenance of safety equipment could save lives, maybe even your own.
This chlorine installation is very good. It's spacious and designed right up to the latest Australian standards, AS 2927.
Let's have a look at the main points of the standard.
Firstly, exclusion of atmospheric moisture from all parts of the system is vital. The most important part of the installation is the auxiliary valve on the end of the pigtail. This keeps moist air out of the system when changing cylinders. Chlorine gas lines should be laid out with a slope back to the cylinder, so that any gas turning back to liquid can drain back to the cylinder, avoiding damage to the chlorinator. The pigtail should be set up with a smooth downward spiral back to the cylinder, again so that any liquid forming can drain back to the cylinder. When the manifold valve is in the wrong position, corrosion can take place. Low points in the line can cause the line filter to act as a liquid trap, causing potential danger when people think the line has been emptied. Pressure reducers, if used on downhill sections, can pass liquid slugs, making chlorinator control difficult. At the lower pressure, after the reducing valve, liquid cannot form. Let's now briefly review what we've covered. Transport of chlorine must comply with the regulations covering dangerous goods. Particular attention must be paid to securing the load. The driver must be trained and licensed to carry Class 2.3 dangerous goods. Any area where chlorine is stored or used must comply with the Australian standard AS 2927. Care must be taken to check and test your work at each stage of connecting or disconnecting chlorine containers. Mastering the methodical approach to valve gland adjustment, connection and disconnection will make chlorine handling a safe process. If there is any possible danger of chlorine escape while carrying out maintenance, play safe by wearing breathing apparatus. Chlorine lines should always be kept sealed to exclude moisture, otherwise severe corrosion will occur.
Well, we've covered a lot of ground in this video. If you have any doubts about any aspect we've covered, then just rewind the tape and go back over it as many times as you need.